Jo, was geht ab? Ja? Was mach in Sache? Jo, was geht ab?
Hello.
Hallo. Can you hear me?
Welcome to Comedy Space. Please like all sexily married. So today, we're going to be taking a look at a woman in the audience.
My house already full of an ass.
Don't let her talk to her.
Oh, man, why don't you stay at home? I want some more.
everyone, this is Anil from Edureka. In this session, let me walk you through a few levels of Python projects that you can use. Well, this session is intended to be useful for anyone considering to kickstart their learning about Python and need some insight about the projects built using the language. Well, the focus is to basically on approaching the language in the easiest way possible and to find out what it has to offer for the community and all of the learning enthusiasts out here. So without further ado, let's begin by checking out the agenda for the session. We'll start with the introduction of Python and later move to installing and working with Python. Followed by that, we look at the overview of all of the concepts and I'll walk you through the 3 levels of Python projects that you can consider. And lastly, we'll look at how easy it is to actually code with Python, where we'll take a programming approach and then learn the concepts through the code. So alright guys, let's begin by checking out what Python actually is. We already know that Python is a programming language, right? Well, to be more specific, Python is a really powerful high-level object-oriented language which was created by a person called as Guido van Rossum. Well, yeah, that is Guido. So why did he choose to name the game and Panda 3D and all of that, right? Well, the major highlight here is that the syntax of the language is clear and the length of the code is relatively short. What is more important is that first of all, it is actually really fun to work with Python and it allows you to think about the problem rather than focusing on the syntax, which is really good, right? And now that we have established why you should consider learning Python, next up, let us quickly check out on how we can install Python on your machines and what development environment you can use. Think about it, it is as simple as that. If providing solutions to various simple and complex problems is your kind of a thing, then you should definitely consider working on projects. And after you have got your hands dirty with a couple of projects, you will be one step closer to mastering Python. This is really important because you will be able to spontaneously implement what you have learned on something as simple as, say, writing a calculator program all the way till helping you achieve artificial intelligence, guys. And that sounds really good, right? So let's begin by checking out some projects in Python that you can go ahead and work with. Well, to keep this session simpler for you all, I have divided the projects into 3 levels, guys. Easy, intermediate and advanced. So let's take it real slow and work our way up. And I'll give you an example project for all of the 3 levels of expertise. And just before we dive into the projects, here's another quick recap of the progress. We start with the fundamentals and work our way through basic code. We then work with easy projects which will only require the base package of Python installed on the native system, guys. In the intermediate project sections, we'll be looking at using external libraries to actually work with Python. Well, nothing very complex just yet. But not to worry, as I said before, Python has amazingly good readability, so you can almost figure out what is happening with code most of the time, even if you're seeing that piece of code for the first time, guys. And then moving on to advanced projects would make sense, right? So using Python for specialized requirements as I previously explained. In my opinion, achieving artificial intelligence is one really good use case of an advanced project in Python. Well, what do you guys think? Head to the comment section and let me know. So next, let us check out our first level of Python projects. So to achieve any answer, we require a question, correct? That forms our problem statement. We analyze and arrive at a solution. Then we check on how we can achieve this with Python, and lastly, Python solves the problem.
I've been eating a vegan diet
there
for
are
3
many sub-levels at this
percentage
stage.
of acne triggers.
We can always start with the hello
60s
world
with
program,
chocolate.
right? We can write simple programs to make
Pounding the
calculations
weight.
easier or any basic programs that solve tiny problems. Next up would be to convert one type requirement into another. String manipulation is very important and it forms as the fundamental for many other concepts that you build up. So it is essential at this level only, guys. And lastly, we have Hangman. Wait, what is Hangman? Well, I'm sure all of us have played Hangman at one point of time in our lives, right? So it is basically a game where you guess the word. It is as simple as that. So we have a hidden word. We ask the user to first figure out what it is. We then give the user a certain number of tries to achieve it. If successful, then the word guess is right. If not, you just ran out of attempts, guys. Pretty simple, right? So let's quickly look at the code and figure out how it works. So guys, I quickly opened up my PyCharm and this is the development environment that I'll be using for this particular project. Let me quickly walk you through the code in a pseudocode format, right? So on the whole, let me explain. Well, first we actually ask for the number of attempts that the user can make. And we will make sure that this follows, right? So we can have 1 attempt, 2 attempts, 3 attempts to guess the word. And we're going to keep a limit on that. So let's say, something less than 26 or something. And then we have a words file. We actually open the word file and we select a random word from there. And then we'll have a while loop to actually guess the number of attempts and the letters which are remaining in that particular word. And you might be wondering what the status of the game is, right? So obviously we're going to keep printing the current status of the game at every point of time. This is done basically using a for loop. And we're going to ask for the next letter and we're going to make it lower, right? So we need to make sure that the input is a single letter that hasn't been guessed previously. If the letter is in the word, we tell the user that the letter in his word exists. Else, we actually decrement the attempt counter because your attempt decreases and you print. That means it became for scientific computing. And SciPy uses arrays like basic data structures, which is used for linear algebra, calculus, and all of that. And pandas are used for data frames, and matplotlib is actually used to visualize the data. And that is exactly what we do in the intermediate project, guys. We first input the data, we analyze the data and process it. Later, we'll be outputting the data in the form of a graph, and this comprises of the output. Pretty straightforward, right? So we'll visualize some data using matplotlib and plot a 3D graph using the same. So let us check out some code for this right now. So instead of PyCharm, now I'll be opening up Google Collaboratory, guys. So we'll check out how easy it is to see the Jupyter Notebook hosted on their cloud. So guys, as I said, we'll be checking out three-dimensional plotting using matplotlib. Well, I won't be explaining all of the code for you guys, but then it's broken down into snippets here, right? So in case you need this Jupyter Notebook, I'll leave a link in the description box below so you can check it out. So let's go ahead and execute this and we can check out how we can do it, right? So basically, matplotlib was actually designed to only do two-dimensional plotting, right? And when it was released, three-dimensional plottings were built on top of matplotlib's two-dimensional display, and the result is convenient, right? So we are actually getting three-dimensional plots out of something which only
Jordan from 995.
So basically, to print that, we'll be using matplot3d, which is mplot3d here. That's what we've imported. So let me quickly go ahead and run. Well, as you can see now, it's connecting to the kernel. So it is actually initializing, and now that we connected, the particular code will execute. So perfect, that's done, right? Well, once the submodule is imported, all of the three-dimensional axes can be created by passing the keyword projection equal to 3D, right? So you can just check it out here, projection equal to 3D. So let me quickly go ahead and run this, and this as well. Well, the figure is basically the plot, and you can actually see the three-dimensional plot in front of you guys. Well, now all of that is enabled, right? So we can actually plot a variety of that. Three-dimensional plotting definitely benefits immensely for the viewing figures interactively than just statically using the notebook, right? So basically, let us print three-dimensional points and lines. If I go ahead and run this piece of code, we'll be actually using the sine and the cos function to actually print a few points for us. Well, the data is completely random, as you can see.
So you've probably heard of
data here where we're multiplying a number and we're actually fetching a random number, right? Whatever the data is plotted is being sent to our trigonometric functions, which is actually printing out the value for us. And we can actually choose the colors, right? So as you can see, the fine curve is actually in gray, but the points are mapped in green. Well, different points of green as well too. Pretty much simple. And next we can actually define contour plots. So contour plots actually use the same relief points with the same inputs, right? So we have the same inputs. Let me quickly go ahead and run this and you're going to see the output. But as you can see, again, so we have labels X, Y, and Z and we have a few points there, right? So we're using np.meshgrid to actually give us this particular output. Again, pretty simple, right? So how we're actually obtaining this is not important for this particular session because we're actually using square roots and we're actually using an equation to give us this. But do note that this can be done and this is very important, right? So that's the major goal of this. So we've been viewing this from a particular XY plane, right? So now let us actually change it. We can view it from another plane. Well, let me quickly go ahead and run this piece of code and you can see that, right? So we're actually viewing this from 60 degrees above the XY plane and we're actually adding an azimuth of 35 degrees. Well, azimuth is nothing but rotating the z-axis by 35 degrees, guys. So do know that it is actually a presentation. Link in the description box below, so make sure you check that out. And torch vision is a part of PyTorch, right? So torch vision actually helps the user to avoid writing a lot of boilerplate code, which I'm sure no one here is interested to write, right? So we understood our problem statement, but what does our input look like, right? So well, since it's this default 10 dataset that I've used, here is what it looks like. So we have 10 data points ranging from aeroplane, automobile, all the way till truck. We have 10 images for each of these data points. So in total, we have 100 images, right? And each of the images is a color image, as you can observe. A color image will always have 3 channels, red, green and blue as in RGB. And do note that in this dataset, each image is of the size 32 cross 32 pixels. So now our input is set, so is the output data. Well, let us look at the entire project in the data flow diagram, right? So check out this quickly, guys. This is an entire flow diagram for how the project actually works, and I'll quickly walk you through the same. So first we'll actually begin by loading our dataset, loading the images in that particular dataset, and then we'll be reading the actual dataset, right? So we need to figure out what the actual data is, and normalization. Guys, normalization is basically telling our program and writing code to make sure our program actually makes some sense of the input, right? So after that, we'll be actually defining a neural network, and we'll be defining the loss function. Well, the loss function is to actually increase accuracy at every point of time, and lastly, we'll be training the network. Well, training the network is actually to reduce the losses at every iteration. Well, as you already might know, that deep learning is a process of iteration, right? So every time the process is repeated and we decrease the loss. And we test the network based on the training data. And lastly, we make predictions on our data set to check if our model has actually learned anything. Well guys, again, it is at this point of time I'd like to tell you that we have a detailed video on PyTorch as well. So make sure you check that out on the channel, right? Well, do not worry if you don't actually understand what deep learning is at this point. But I'm just trying to paint a picture in your head on how you can use Python even in this advanced levels, right? So well, now that this is done, let's quickly look at the code for this and run the project. So the first step, as I mentioned, is to actually load and normalize SFR10. So guys, as you can check out, we're using Torch Vision package to import our images here. So the first step here is to actually download the SFR10 from their database, guys. We need an active internet connection at this point of time and make sure you have that. So at this point of time, all we have to do is we need to download the dataset and we need to make sure that our network can actually figure out all the classes. So we have defined the classes ranging from plane, car, bird, all the way till truck. So as soon as I go ahead and implement this piece of code, SFR10 should be downloaded on my machine and the classes should be actually identifiable. So this might take about 2 to 5 minutes based on your internet speed, guys. So as you can see, in my case, it says files are already downloaded and verified because I've actually done this code. You will need to run this piece of code only once because SFR10 is actually downloaded and cached on your local machine. And hence you don't have to download SFR10 every time you need to execute this piece of code. So guys, we've been talking code all this while and we need to start showing images and we need to start making it interactive. So let me go ahead and actually show you some of the basic training images from our dataset. Here we're using matplotlib and numpy and we have defined a function IamShow. IamShow is basically used to map the label and that particular image from our dataset. And let us get some of the random training images from our dataset and we'll be printing the labels along with them as well. The machine and we'll have the output from detection of labels and the image corresponding to them. We looked at why Python projects is so Python learning. So thank you guys, you know what to do.
Hi there, thanks. Hey everybody, this is Roberto Blake helping you create something awesome today. Welcome back to the channel. So today I want to talk about something important. I want to talk about 10 ways that you can make money on YouTube. Now in 2 of my previous videos we talked about YouTube money, but we specifically talked about YouTube AdSense revenue. And I actually showed you my real earnings from YouTube AdSense in the YouTube dashboard. And I also showed you a video where I broke down how much YouTube paid me for a video with 1 million views and also how much they paid me for 1 million views on the entire channel in a 90-day time period. So if you want to check out those videos, they're going to be linked in the info card up here and in the description down below. And the reason I made those videos is because I try with this channel to be very transparent about how much money did YouTube pay me for my most popular video with over 1 million views. Well, today we're going to find out. Hey everybody, this is Roberto Blake helping you create something awesome today. Welcome back to the channel. For the new people here, first of all, welcome. Thanks for watching. My name is Roberto Blake. I'm an entrepreneur, public speaker, and today we're going to talk about YouTube. We're going to talk about my YouTube AdSense earnings. In a previous video, I showed you how much money I make on YouTube. Today we're going to see what YouTube paid me for a video with over 1 million views. We're also going to look at a 90-day cycle where I did 1 million views on the channel and how much YouTube paid me for that. We're going to tell you the truth about making money on YouTube ads. the reason I want to do this video is there is so much misinformation out there about YouTube, and how much YouTubers earn is a topic of speculation, and often the media gets it wrong, but you also have a lot of videos that I just feel like cover this topic and they don't do it well. Now, there are some great channels that have done an amazing job with it, but there's just a lot of information you don't know if you're trying to become a YouTuber, and I want to try and debunk some things that might be out there. A lot of you might have heard that you make $25 to $2 CPMs, and that's not entirely true, and that's not what you could call normal. There is no normal in YouTube. So that information is a baseline that people like to use to speculate on how much money YouTubers make. If you go to Social Blade, you'll see a lot of information about how much money YouTubers make, but it doesn't account for anything. It doesn't account for what country their views are in. It doesn't talk about any of the really deep dive stuff that helps you get higher CPM rates. And the numbers are just inaccurate. If you've seen my videos, and you'll see the data here for yourself, those numbers are not accurate at all with regard to how much money I make. So they're probably not accurate with how much money most people make, or even what you can expect to make. Now, my most popular video on YouTube is passive income, 10 ways to make passive income online. I published this video back in May of 2016. Now, according to YouTube analytics, that video for 1.4 million views earned me $9,836.32 as of the making of this video. So that's actually really good, and for 1.4 million views, that's a lot of money. It had an average CPM of about $12.32. So nice, right? Now, that video is one that took off over a period of time, as you can see, and for years after I published it, it was still making me money. It was still making me real passive income, making me hundreds of dollars a month. Long after I published this video, there were months back to back where I was making $500 or $600 off of this one video every single month, which is insane. That is crazy to think about. Now, there are other videos that I've done that are close to that in terms of what they earned, and they did it with a lot less views. And so I'll give you an example. An example of that would be a video that I did on affiliate marketing step by step. It's another one of these videos in terms of how to make money online. $100 a day in passive income. That video did 133,103 views, so about 130K views, and did $3,024.70 in revenue. Not bad at all. If it had done 10 times as many views, just like the previous video, then it might have made me as much as, if we're doing the math here, $30,000 on the video. Now, it probably would have been less, but it still would have been close to $20,000 if I'd gotten that video to 1 million, because that video has extraordinarily high CPM rates. So when you really think about it, when you look at these videos, they're wildly different, and the data here is crazy in terms of how much a video can be worth. Now, there's a video where I did 360,000 views, how to get 10,000 subscribers in YouTube. That video did $2,546. So that is a big gap between 130,000 doing more money than that. And why is that different? Why are two videos on the same channel getting wildly different ad rates? Why do they have wildly different CPM rates? Because the videos reach different audiences. Even though my core audience is a little bit older, when people want to know how to grow on YouTube, you get a little bit of a younger audience on those videos, and you get people from all over the world watching those things. And based on age and demographics, geography, there are a lot of factors that go into what ads play on a video. A video that talks about money or passive income will get completely different ads from a video talking about social media, or anything entertainment based or popular, or a vlog will not make nearly as much money as a video that is on personal finance or real estate or, again, marketing. They'll pull completely different advertisers and a completely different audience that is valued differently. And so it's going to be worth more money to do some categories in YouTube than other categories in YouTube. I would say the lowest CPMs are probably in comedy and in gaming and maybe even vlogging. So you just have to think about what ads could possibly run against your videos, what brands would market against those videos, and how much do they sell a product for, how much is advertising worth to them, what are their budgets like. So these are things you really have to think about. There's also the simple fact that not all videos are monetized equally. Just because you got views doesn't mean those views had ads attached to them. Now, a lot of people think that I run multiple mid-roll ads on my videos, and I don't. I very rarely put a mid-roll ad in a video. I do it on occasion, but most of my videos, if you're a long-time viewer, you know that I have an ad at the beginning of a video, an ad at the end of a video, and that's usually it. Now, what a lot of popular YouTubers will do, because their ad CPMs are so low, they have to do multiple ads in the middle of a video to really make any significant money on AdSense. That's why so many YouTubers do sponsorships and merchandise and other things to be able to make money. And I don't fault them for that at all. I've always talked about the fact that you need to diversify your income and that AdSense is not a stable way to make money. And that's why I'm making this video and why it's so important. Now, all that being said, I want to show you something really interesting. And to do that, I'm going to have a mid-roll ad right here. Now, if you got through that mid-roll ad, assuming you saw one, then I want you to understand something. Whatever advertisement you just watched is considered a monetized view. And for most YouTubers, the far majority of their videos, the ads on the video show up on only 30% or less of all the views that they get. Now, in other niches, specific niches like entertainment or gaming, a lot of those people might have ad block, and so less of their views are monetized. More than 60 to 80% of my views are monetized in a given period, which means that for me, I actually do a lot better than most YouTubers in terms of my views getting ads playing on them, and so I would make more money on those views, even if I get less of them. So that's just kind of a given with what happens in my channel. And that's different than other people. I don't say that to brag, I say that to just give you the real example of why would somebody who has less views stand to make more money on YouTube, because it's possible. And also, if you're a smaller channel, maybe that makes you a little bit optimistic. Maybe you're a little bit more optimistic about what your earning potential in YouTube could be. Now let's look at the last 90 days. So in the last 90 days, and I'm pulling the data here on my laptop, looks like the battery's gonna die, just a little over 1 million views, is worth over $7,000 on my channel. So as you can see, there's a lot of opportunity for you here in YouTube. Depending on what category of YouTube you're doing, it might be more worthwhile in ads, but otherwise you might need to look at other revenue streams. CPM rates are not guaranteed. As you can see, you might be getting 25 cents for CPM rates or $25. And it really depends on what the videos are and also whether they are monetized. You might not be worth as much in terms of monetized views if you're cursing, anything extreme, or covering sensitive subjects. So that matters. Channel authority and watch time matters. More than views. Cash over clout, my friends. Cash over clout. I keep saying it in Twitter. Follow me on Twitter at Roberto Blake if you're not already, by the way. So let's talk about some ways that you can make more money on YouTube. I think that's really important. We saw like what 1 million views is worth, but I don't need 1 million views to be successful in YouTube and to make a substantial amount of money. We also know that that's not the money that I make every single month. I make money off of affiliate marketing through the links that I use in the description for camera gear or for products. We also know that we do sponsorships. In my case, I am very good at business, and I'm in a different category of YouTube than an entertainer. I speak to an older audience with disposable income, and I have proven sales numbers. I can prove that I can convert sales. So when I go and I negotiate a brand deal, I'm able to get a lot more money because I'm not using my views as my leverage. I'm using my authority as my leverage. I'm using the fact that I'm a public speaker. I'm using the fact that I have an email list to include in the deal. I'm using the fact that I'm positioned very uniquely in the market. And those are things you need to understand about negotiating, which I'll cover in a completely different video. I've done videos on negotiating and how to sell, but a lot of you skipped over those because it didn't have the words YouTube in the title. So we'll figure that out later, and we'll make some clickbait title just for you. Now, when it comes to how to make money outside of YouTube. I think this is important because a lot of you are hoping to go viral, and we've seen it before. Ice Poseidon put out some information where he showed that on a video with over 1 million views, he only made $500. As we know that for me, 1 million views would be worth so much more, and it's because I get different CPM rates. And again, your CPM rates might be lower if you have viewers that are in another country. Ad rates are best in like the US, the UK, Canada, Australia, places like that. They're not as good in other places. If you're getting a lot of views from maybe South America or India or parts of the Netherlands, they may not be worth as much money, and there may not be as many ads to play against those videos. Or if your audience is blocking, they have VPN, they might be routing through a country that has no ads or lower ad rates. They might be using ad blockers. So those are all things that could affect your revenue. I honestly believe that it's easier to make $1,000 freelancing or doing a number of other things online that I've talked about than making money on YouTube ads. It's not as glamorous as it looks, and that's why I want to show you guys the real numbers. Now, it's also not as bleak as the media paints it out to be. Media would have you believe that every YouTuber that's not at 10 million subscribers is living in poverty, and that's just not true. But at the same time, when that's not the narrative is that, anybody with 100,000 subscribers must be rich, and that's also equally not true. The truth is that YouTube is an individual experience. Your mileage may vary. What somebody else makes is not really any of your business beyond the fact that maybe it's useful information, but if you're not doing the type of content that person is doing, or you don't have the type of audience that that person has, or any number of variables that you can't know or control, then your results are not going to be that person's results. Just because I make a certain amount of money on YouTube, does that mean that that's the normal? And I think that so many of you get tripped up, and the reason there's so much misinformation and so many myths and rumors out there is not because YouTubers aren't being transparent and not because a bunch of us aren't making these videos. We are, but people are taking it out of context and saying, oh, so that's what I'm going to make, or that's going to be me, or that it's not. You have to run your own race, have your own journey, have your own experience, because I have data on multiple YouTube channels, and nobody's CPM rates are the same. There's no normal. Nobody's ad rates are the same in terms of how many of their views are monetized. It's not.
Hi guys, I'm Rahul from Simply Learn, and today I'm going to tell you how you can become a machine learning engineer. But before we begin, let me tell you what a machine learning engineer actually does. A machine learning engineer creates and maintains machine learning solutions to solve business problems. They constantly tweak and optimize the solutions for maximum performance and scalability. They solve business problems like reducing customer churn, running targeted marketing campaigns, and improving product experience. They also help with predicting whether a particular hypothesis will be profitable in the future. They contribute to cutting-edge research in AI and machine learning. Now, before you can start off on your journey to becoming a machine learning engineer, there's a certain number of steps that you need to follow. On this learning path, your first step is to improve your math skills. Mathematics plays a very important role in helping you understand how machine learning and its algorithms work. Among the many concepts that you need to understand, 3 of the most important ones are probability and statistics, linear algebra, and calculus. Now, let's have a detailed look at probability and statistics. Firstly, you have the Bayes theorem. This is used in the naive Bayes algorithm to help categorize your data. Then we have probability distribution. This helps you determine how frequently a particular event will take place. For example, you can determine what your premium for your insurance will be based on the probability distribution of expenditure pertaining to insurance claims. You must also learn how sampling and hypothesis testing works. Now, let's look at linear algebra. Now, linear algebra has 2 main concepts, matrices and vectors. They both used widely in machine learning. Now, matrices are used for image recognition, where the entire image that you're using is already in the form of a matrix. You need to be able to work with matrices, perform simple operations like addition, subtraction, multiplication, inverse, transpose, and so on. Now, the recommended systems that you see in applications like Netflix or Amazon actually work on vectors. This vector is the customer behavior vectors, and they use distance measures. Now, let's have a closer look at calculus. You have differential calculus and integral calculus. Now, these help in determining the probability of events. For example, in finding the posterior probability in a naive-Bayes model. In your next step to becoming a machine learning engineer, you need to develop good programming skills. And let me tell you, there are a huge number of options from which you can choose. There's Python, there's C, there's C#, there's Java, and so much more. Now here's a graph of the job postings from 2014 to 2017, and you can see that there are two languages that dominate since 2015, Python and R. Now these are one of the most wanted languages when it comes to machine learning engineers. These are closely followed by JavaScript and C. Hence, we would like to recommend that you learn Python and R as they're the best options when it comes to coding in machine learning algorithms. So here are a few things that you need to know about Python and R. Python is an object-oriented language, which means their main emphasis is on the object. R is a functional language, which means their emphasis is on creating and manipulating functions. Python relies on its many packages, and R is slightly faster than Python because it has inbuilt packages. Now Python is generic and is suitable if you need to integrate it with any other software. R works a little more closer with statistical analysis. Your next step is to get yourself some data engineering skills. Now these skills are important as they help you analyze and process your data as soon as you get it. Now there are three major steps when it comes to data engineering. Firstly, there's data pre-processing. Now these refer to all the steps that you need to perform before data can be processed by the machine learning algorithm. You have cleaning, parsing, correcting, and consolidating the data. Then you have ETL or extract, transform, and load. You need to know how data can be extracted from the internet or a local server. You need to know how to transform the data. For example, not all formats of data would be accepted by the program. So you need to convert the data into a format that is accepted by the program. Then you need to know how the data is loaded into your program. The final step is to have knowledge about database management softwares or DBMS. You need to be well versed with MySQL, the Oracle database, and NoSQL. Your next step is to learn machine learning algorithms. Now, among all the machine learning algorithms that you can see on screen, you can divide them into two different categories. Ones that fall under supervised machine learning and the others that fall under unsupervised machine learning. Even after such a division, you can further subdivide them into classification and regression algorithms. Now, all algorithms except linear regression fall under the category of classification, which is used to determine whether a particular data falls into a particular category. On the other hand, you have linear regression that falls under regression algorithms. This is used to predict a particular value. Then you have k-means clustering and hierarchical clustering. Now these fall in the category of clustering. This is used to group data into clusters based on certain similar attributes. Then you have the a priori algorithm that falls under the concept of association. Association is used to determine patterns of association among variables in large data sets. So now that you know about these algorithms, let me tell you where you can learn about them. Let's take a look at our Simplilearn channel. And let's go to playlists. And on this, we have a dedicated set of playlists that talk about machine learning. Here you have videos on machine learning, how machine learning is different from deep learning and artificial intelligence, machine learning with Python, k-means clustering, decision trees, and so on. If you want to learn more, you could also go through some deep learning algorithms like convolutional neural networks, recurrent neural networks, long short-term memory networks, and so on. In fact, we have a detailed playlist that talks about the concepts of deep learning. Here you can find videos on what is deep learning, TensorFlow, what is a neural network, convolutional neural networks, and recurrent neural networks. Now, after you master these algorithms, you need to learn how you can select the right algorithm for your problem. Then you need to create a good model with one or more algorithms. After which you need to keep tweaking and optimizing the model so that you can get the maximum accuracy. For further reading, you can go through GitHub where there's more than 21,000 repositories under machine learning. You can also recreate published research papers, adding to your experience of working with machine learning. And now for your last step, learning machine learning frameworks. Machine learning frameworks help make the lives of developers as well as users a whole lot easier. They help remove the complex part of machine learning and make it available for everyone who wants to use it, be it developers or other users. Now let's look at the widely used machine learning frameworks. There's TensorFlow, Theano, Torch, Scikit-learn, and so on. Now let's look at some of them in detail. First, let's look at TensorFlow. TensorFlow is the most widely used machine learning framework. It's used for machine learning as well as deep learning. Now, it's an open source software library which performs numerical computations, which is done with the help of data flow graphs. Google Translate is one of the most popular use cases of TensorFlow. Now, let's look at Theano. Theano helps you define, optimize, and evaluate mathematical expressions. It was developed in the University of Montreal. Dasani, Blocks, and Keras are its most popular libraries. Now let's look at Spark ML library. Now this is Apache Spark's machine learning component. It also provides libraries for machine learning which are built on top of RDDs or resilient distributed datasets. It's very good at providing iterative computation and provides very high algorithmic performance. Now let's look at scikit-learn. Scikit-learn is able to provide a huge range of supervised as well as unsupervised algorithms for machine learning. It is built on existing libraries like NumPy, SciPy, and Matplotlib. Scikit-learn actually started off as a Google Summer of Code project and now has 23,000 GitHub commits. And that's it. Congratulations, you're now a machine learning engineer. Now let's look at the job opportunities in machine learning. Now if you have a look at this graph, it kind of speaks for itself. Before 2015, machine learning was much less popular than big data and cloud computing. But all of that suddenly changed. And right now, a machine learning engineer earns around $114,000 per annum. And this is a clear indication that organizations are ready to invest heavily in people who are skilled in the concepts of machine learning. You can also make the learning process easier by using Simplilearn's machine learning certification. Simplilearn's machine learning certification course provides 36 hours of instructor-led training, provides 25 plus hands-on exercises, gives you practical applications of 15 plus machine learning algorithms, and helps you master the concepts of supervised and unsupervised learning. It also introduces you to artificial intelligence, tells you the techniques of machine learning, data processing, regression, classification, and so much more. So if you want to take your first step to getting certified and getting ahead, click on the top right corner immediately. And with that, we've reached the end of another video. I hope you guys found this informative and helpful. Thank you for watching and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.
So welcome back to my tutorial pre-contact application. In this episode we will be creating and connecting data app. So without further ado, then give the name of the database. I'll give e-contact and click on OK.
Oh, cool.
Let's refresh. Here is our database. Just expand it by clicking on plus sign. Then go to the tables. Right click on tables and click
Hey folks, Knox with IT Inspired here. Man, we are going to have some fun with this. In a previous series, we went over SQL Server. That was choosing the career path, installing and configuring the SQL instance, basic development and querying, then the administration fundamentals such as backups, user permissions, and migrations. But we didn't touch on the front end of an application, that's like the website itself, and we didn't touch on the cloud at all. So in this video, we are going to build a front-end web app that is going to use a SQL backend. We're going to host it all in the cloud in Azure, and it's going to be free. You heard that right. We're going to do development, SQL, the cloud, all in one video, completely free. So let's get started. Okay, so here's the scenario. I'm going to have a party. I want to have a party, and I need to know who all is going to come to my party. So what I want to do is I'm going to build a super basic website where it's going to have a text box in it. People can go to this website, they'll type their name in the text box, they're going to click submit, and that's how I know who all is coming. That when they click submit, it's going to insert their name into a SQL database. So we're going to have this website hosted in Azure as well as the SQL database. And I'm not talking about spinning up a VM, installing IIS or Apache on it, and building a website. But no, we're going to have Azure handle all of the server maintenance and all of the hosting itself. We just want them to publish our website. So the first thing we have to do is minimize paint. You can kind of see what's happening here is we're going to do all the development on our desktop or our laptop, whatever you're using. And here's the cloud. You can kind of see how it's going to look. The first thing we got to do is we've got to provision this space in Azure itself. If you didn't watch the previous video on standing up an Azure SQL database and integrating it with Active Directory, don't worry, these steps are almost identical, so we're going to cover them all here. But if you do want to integrate into the Azure Active Directory, we're not going to cover that in this part. You probably do want to circle back to that video and pick it up around the 10-minute mark. Okay, so let's get started. Let's stand up a website and the database connected to it in Azure. So the first thing you're going to do is you're going to log into portal.azure.com with the account that you've already created, hopefully, and got the $200 credit. And what we're looking to do here is we're going to build an app service. The app service here means that it is going to be hosting the application itself. And what you're about to see is it's actually overwhelming the amount of options you have. This is one that I've created already. This is kind of the dashboard that you land on if you've already created stuff. But if not, it's going to tell you, hey, this is empty, let's add some services. So we're going to click Add. And right off the bat, you can see how many options that there are here for many different kinds of services they have. It's not just web apps. If you need to build firewalls, you can actually spin up like Sophos or Palo Alto firewalls in these services. You can spin up business and 30, right? You get the Azure together, right? Type your button, insert, dot. So the IntelliSense has had sensitive, so make sure you get that right. And another thing I'm going to add, just for good measure, right underneath this first files, I'm going to open up this and say clear, and it already knows to do / and close. All right. Let's save the web.config and close the web.config. Let's go back to portal.azure.com, ASPX to get to our site. And it doesn't let it do its job. Data was inserted. The final test to make sure this works. We'll do that. Hey, look at that. There it is. Look at what you just accomplished. You created a web form using Visual Studio Code, Visual Studio 2017 Community Edition, locally on your machine. We did C#, we created buttons and text boxes, we provisioned space.
Hey, this is Tim Corey, and I want to introduce my new C# application from start to finish course. In this course, I'm going to show you step by step how to take an application from its idea stage all the way through being built. So the idea for this application is that our friend wants us to build a tournament tracker, something that can be used to track a game tournament of some kind. For example, in America, we just finished the NCAA basketball March Madness tournament. In it, 64 teams play through 6 rounds of single elimination games to determine the champion. The brackets look... Oh, that's what you want. Return. Shit.
Hello, welcome to this lesson where we're going to talk about different back-end options for your app. So first of all, what is a back-end and why do you need one? You may have noticed that a lot of the beginner tutorials on iOS, you build simple stuff like calculators or maybe news readers or something like that, and it's purely one-sided. The user is only consuming content and not producing content. And the reason why is that as soon as you get into the realm of user accounts, or account management, or producing content, that data that the user produces, or that account that they created, needs to be stored somewhere. Like that information, that data, it needs to exist somewhere. So that's where we get into the back-end territory, where we need some sort of data store or database to hold that data. And furthermore, in the case of the user producing data, that needs to be seen by other devices or other users, it's not enough to store the data locally on the device. You actually need to store the data somewhere that all of the different users can access that data. So here are some examples where you would need to consider a backend for your app. So if you have some notion of user accounts, whether that's logging in or creating an account or registering, whether you have leaderboards, if you have users posting or generating content, if you're messaging other users, if you're liking content, you need to store that relationship somewhere. Or even if you want to implement the functionality where you sync data between different devices. So if a user uses 2 different devices and you want to sync that data between those 2 devices for the same user, you would still need a backend. So let's take a look at the diagram and see what this sort of setup looks like. I mentioned a little bit about a server and a database, but visually, what does that look like? So in this diagram, we have 2 people, client A and client B. They're using the same app on their respective devices. And we have a server. So a server is usually a physical piece of hardware. It may be a computer, it may be, well, generally it is a computer that's specifically built to handle incoming requests from clients and then return the appropriate response. So the server is a physical piece of hardware, and a database is more of like, it's not a physical thing, but it's a way to store data in a organized and relevant format, which makes it easy to query and return data or to populate data. So a database is just a system of data management, but the actual data is stored on hard disks in the server. So for client A, if the user is creating an account or generating some content or liking something, or maybe they got a high score and you're posting it on the leaderboard, client A would send that data to the server as denoted by those arrows, and then the server would store that data. Now client B, another user somewhere else, using the same app, when they send a request to that server to return, let's say, all the high scores or all of the latest messages, or different users that are on their friends list or whatever, the server returns that data to client B, which includes the data that client A just submitted to it. So in this way, you have multiple clients sending data to the server to store on the database, and the server also retrieves and sends information back to the client to display. Now this is a simplified example because in reality you probably have not just a single server, but it'll be distributed between multiple servers. But the idea is there. So if you need to store data or sync data across different devices, you're going to need to implement something like this following diagram. This shows how an iOS app would interact with a traditional MySQL database. And if you're not familiar with MySQL databases, they're most often used with websites and web apps. But whenever I teach iOS to beginners, I get an overwhelming request for showing people how to interact with a MySQL database. So this diagram illustrates how that would work. The iOS app can't connect to the database directly. Instead, you need to build additional server-side architecture, which I have written there as web services, which is essentially just code that sits in between the client and the server. It handles the requests from the client and then interacts with the server or with the database. I guess in this diagram it's not completely clear, but the web services will connect to the database and then either query data for returning to the client, or it will insert data into the database. So the iPhone app can't connect to the database to do that directly. And so you have to learn another programming language and build additional infrastructure just to interact with that MySQL database. However, this isn't the only option for a backend for your app. Recognizing that people just wanted to build apps, not necessarily fumble around with server-side architecture and server-side code, these things called a backend as a service started cropping up. And essentially, what they do for you is remove away all of that complexity and just gives you a set of web services to interact with. So you don't even have to build the web services, you don't have to set up your database, you don't have to worry about that database architecture. All you need to do is send the data from your client to the web service and then query the data back. What happens behind the scenes, you don't have to worry about. And to make it easier still, a lot of these platforms have frameworks or SDKs that you can add into your Xcode project. So you don't even need to create a request and send it to the web services. All you need to do is stay in Xcode and read the platform documentation on how to save data and how to retrieve data. So what are some of the advantages for using these platforms or backends as a service? Well, to me, the biggest advantage is that you can stay focused on building your app and you don't have to worry about setting up all of that server-side architecture. It's also very scalable and secure. A lot of these platforms are built for the purpose of just being the backend for your app. And so if your app takes off and becomes really popular, you don't have to worry about buying more servers and replicating your database across the servers and all of that stuff, because these platforms are built for that and it just kind of happens automatically behind the scenes. It ends up saving you a lot of time because it's not just the setup, right? It's the maintenance as well. So if you have your own databases and your own servers to worry about, you're worrying about your servers and keeping them patched and up to date. If you get attacked by hackers or something like that, then you're worried about getting your servers back up and running. Not to say that these platforms can't be hacked or can be under attack, but it's just that you won't have to worry about getting them back up and running. And lastly, these platforms make it really easy to use. Like I mentioned, they have frameworks you can just add to your Xcode project and start using. So in the following lessons, we're going to be looking at one of these backends as a service called Parse. And it's got a very generous free plan, so you don't have to worry about paying unless your app becomes really popular. And it's actually my favorite one out of them all. If you're interested in MySQL or using iCloud as a backend, then check out the iOS Toolbox course on my site where I cover those two platforms and many other topics. But in the upcoming lessons, I'll show you guys how to integrate Parse into your project and how to save and retrieve data. Alright, bye for now, and I'll see you guys in the next lesson.
turret has been destroyed. An enemy has been slain.
Never settle for second. me, obviously, it's skateboarding, but anything you do in life, be dedicated to and be passionate about. And I've been skateboarding ever since I can remember, and I want to keep doing this shit as long as I can until death.
Show me what you're all about. I got wasted.
Hopefully you got that.
How to let it out. Please don't fake it, fake it, fake it.
Hi, and welcome back to another episode. My name is Patrick Xu, and I am the Tech Lead. Our topic today is how to learn to code. And there's really only one skill that you need to have to learn to code. And generally, people either have this skill or not. And that is really the ability to just sit at the computer for many hours at a time. All engineers know that there's something called the zone, where they basically just sit at a computer uninterrupted for long periods of time, and that's how they are able to put together complex thoughts, chain together many pieces of logic, and basically put a program together. And this is a habit that a lot of people don't have. Like they sit down for 10 minutes at a time, they don't really have a desk maybe, they're like watching TV as they're using their laptop, and then checking their phones all the time, and then they gotta get up and bake a cupcake, and then go walk the dog, and then they gotta go drive out and do an errand, go shopping, come back, and then they gotta go and meet up with their friends. And
I'm always nervous on occasions like that. And he said, so am I. I said, really? The richest man in the world is nervous because he received the Axel Springer Award? So be a bit forgiving. We are both nervous. Jeff, we are so glad to really celebrate you tonight. Most importantly, apart from all the reasons that we heard, because you are a role model for other young founders, for entrepreneurs who really have great ideas, crazy ideas, unconventional ideas, and need encouragement to simply do it and go for it. And you have shown it to the world. So that is really, for me, the most important thing. And in that context, the first question, you used to work in New York as an investment banker. So an investment banker is actually the exact opposite of an entrepreneur. He's delegating risk to other people. And basically, how did you find out, or how did you think that you should move from investment banking to really launch a company?
I think I'd always wanted to do it, even since I was a kid. Had the idea, one of the people who every time I look at something, it looks like it could be improved. You know, there's something wrong with it. So I go through like, wow, how could this restaurant be better? How could, and so I've always had that kind of idea. By the way, before we really get into this, how about this amazing production that you and your team have put together? This is truly incredible. For its originality, like these boxes that you were filming live, that's just crazy cool. So thank you.
That you like it.
Truly, it's incredible. But I think the great thing about humans in general is we're always improving things. And so entrepreneurs and inventors, and if they follow their curiosity and they follow their passions and they figure something out and then they figure out how to make it better, and they're never satisfied. And And you need to harness that. In my view, you need to harness that. That might be a winning approach in some cases, kind of close following. Let other people be the pioneers, and and go down the blind alleys. There's many things that a new inventive company tries won't work, and so those mistakes and errors